And so we begin our journey with functions. If I asked you all each what a function was, you'd probably have some ideas that come to mind right away, some of which would be kind of right, some of which would be not quite right, and perhaps some of you have it right on. But what we would like to do for our class is to make sure we have a solid definition to which we always refer when we are talking about a function. Okay, so let's come up with our definition. A function is a rule which takes certain numbers as inputs and assigns to each input number exactly one output number. So we have an input and an output. Some of you may have seen a function box. So we have input values going in, we apply a function to it, and outcome, your output. So this x in this case represents input, and f of x represents output. So we can associate a function as a set of ordered pairs, where our first coordinate represents the input, and the second coordinate represents the output that's associated with that input. And recall, by our definition, for each input there is exactly one output. A lot of times we see those sets of ordered pairs as xy's. First coordinate x represents our input, and the second coordinate y represents our output. And f of x equals y is interchangeable in this situation. Okay, let's look at some examples of some ordered pair of a function. One way that we see a function represented is as a set of ordered pairs. Let's look at that. Function represented is as a set of ordered pairs. So, for example, this set contains 1, 2, 3, 5, and 6, 8. Now this is a set that contains 3 ordered pairs. It's a finite set, but notice my definition is satisfied. For each input, there's exactly one output. Okay? So in this case, if I were to list my input values, 1, 3, 6, and list my output values, I would have 2, 5, 8. So for each input, there's exactly one output. We could have a set of ordered pairs that was infinite. Let's look at this example. I'm going to use these dots to represent that this pattern that I'm about to display repeats. This is just some, and you all could probably see the pattern that is developing here. I'm going up each x-coordinate by 1, and we can assume that's what's happening to the left, and I'm going up each y-coordinate by 1, and we can assume that that's happening to the right. This is an infinite set, but we notice that the definition is still satisfied. For each input, there's exactly one output. Okay? Sometimes we see functions represented, so another representation is as a formula. Is of a formula. So for example, f of x equals 3x minus 1. You all probably recognize this as a linear function. Okay? And in this case, my input values are the x's, and my output values are 3x minus 1's. So given my x that goes into this function, out comes 3x minus 1. For each input, there's exactly one output. Now, this formula will generate a set of ordered pairs. actually infinitely many, so we certainly can't list them all here. So let's just list a few. When x is -3, your f of x, or your y, is -10. When x is 2, your f of x is 5. When x is 0, your f of x is -1. When x is 1/3, your f of x is 0. And we could keep going all day long, but certainly we don't have time. But this is a representation of your function as a formula as a set of ordered pairs. Sometimes we see a representation of a function as a graph. So, for example, let's just do a sketch of a graph here. We'll let the horizontal axis represent our input, and we'll let the vertical axis represent our output. Right? So each point on my graph represents an ordered pair that corresponds to my function. The x is my input, the y is my output, and it creates this graph. Is our definition still satisfied? It is. Given any x that I choose, there is exactly one y that corresponds to it. So our definition is still satisfied. Okay, sometimes we see a function described in words. Of a function. It's described in words. So, for example, for every hour Samuel works, he earns $10. Okay? Notice this describes a function whose input, which we'll represent as x, is the number of hours worked, and the output, your f of x, is amount earned. And notice f of x here would represent 10x. So hours worked goes into my function box, and out comes 10 times x, or the amount earned. Okay, we have described 4 representations of a function. What are they? Remember them.